In this lesson, we are going to look at what a hypothesis is. A hypothesis is a prediction of what you think will happen in your research. And there are various types of hypotheses that we're going to look at. The first thing you need to do is to take a page and write down hypotheses, and these are the key terms that we'll be looking at today. So there's the alternate or the experimental hypothesis, and these can be one-tailed or directional, or two-tailed, also known as non-directional. There is the null hypothesis, and lastly, for correlational research, we have the correlational hypothesis. The alternate or the experimental hypothesis is basically the same thing. It's your prediction of what you think will happen whenever you manipulate the independent variables. So what effect do you think it will have on your dependent variable? Your one-tailed or directional hypothesis means that you will predict what direction the effect or the difference will be in. And two-tailed or non-directional just means that you say that there will be an effect, but you don't say in which direction the effect will be. Your null hypothesis is when you predict that there will be no effect, and your whole point of carrying out your piece of research is so that you will be able to reject this null hypothesis and accept your alternate or experimental hypothesis. And you do that by carrying out inferential statistics, and that's not something that you need to look at until A2. And your correlational hypothesis predicts that there will be a relationship between your two covariables, and you can predict what direction that relationship will be in as well. Here are a couple of examples of your hypothesis. For a happy dog will eat more is a one-tailed hypothesis. We have said there what direction the dependent variable is going in, so there will be more food consumed. A two-tailed hypothesis will just say that mood will affect the appetite of the dogs, but it doesn't say whether they will eat more or eat less. So the one-tailed hypothesis is also known as directional, and the two-tailed is also known as non-directional. Your first task then is I want you to imagine that you're going to carry out a laboratory experiment. Your independent variable is meditation, and we're going to see what effect meditation will have upon your dependent variable of academic performance. So if you had a group of participants, you may decide to do an independent measures design. Half of your participants may be in the group that receive training in meditation and practice meditation before doing a test, and your other group would not receive training in meditation and would not meditate before a test. Your dependent variable then of academic performance would be, for example, how well they do in a psychology test out of 100. So to operationalise academic performance, you could have percentage scored in a psychology test. Your task now is to write an alternate or experimental hypothesis. It can be one-directional or two-directional with the IV meditation and the DV of academic performance, but remember to operationalise your DV and state how academic performance will be measured. The null hypothesis then, as it states here, the assumption you're beginning with and the opposite of what you're testing. So I want you to do the same thing as you did for the alternate hypothesis, where your independent variable is meditation, your dependent variable is exam performance, and instead of writing an alternate or experimental hypothesis, I want you to write a null hypothesis. And remember, for your null hypothesis to put in, there will be no difference. The next type of hypothesis that we're going to look at is correlational hypothesis. So here we have a scatter graph showing the relationship between average number of hours of television watched daily and teacher ratings of aggressive play in children. So this correlation was carried out to see if there is a relationship between the two variables, and you can see they have been plotted on the scatter graph and that there is a positive correlation between these variables. Your task now is to write a correlational hypothesis for these two variables, beginning with there will be a correlation between. That is how your correlational hypothesis should always begin. You should not be mentioning differences or effects, and you don't need to state if it's a positive or negative correlation. So an overview of conducting your research: you will first of all start off with a question in your head. Does mood affect how much a dog eats? Or you might want to ask, does practicing meditation before an exam have an effect upon exam performance? Maybe you will conduct background research into that area to see what other research has been carried out and what the general consensus is. And then your third step is what we're looking at today, is to construct your hypothesis. So what you predict will happen. And then for experiments, the whole purpose of carrying out your research or your experiment is to test that hypothesis to see whether you can accept your alternate or experimental hypothesis and reject your null hypothesis. And you will be able to do that once you've collected your data and carried out your inferential tests, and then you'll be able to see whether your original hypothesis was correct or not. So to recap, what you need to know for hypotheses are you need to be able to write an alternate or experimental hypothesis. You need to be able to write a null hypothesis. You need to know the difference between a one-directional and non-directional hypothesis, or one-tailed and two-tailed. And you also need to know how to write a correlational hypothesis. And we'll be doing some practice with that in class next day. But make sure that you have the short activities done for this lesson for tomorrow. Thank you.